Let's leave off. I'll leave off the using namespace standard this time around and put it in there. So definitely C and C++ is a language of expressions, where an expression is 4 plus 5 divided by 3 times 2. And one of the primary purposes of a semicolon is to tell the compiler, this is where my expression ends, this is the end of my thought, right? So with that as a backdrop, there's let me introduce another variable type. So what have we seen so far? The character, the char, the integer, the float, the double, and I think I said there are things like long integers, the string. May talk about this more later on, but you'll notice that string is not a type that gets the courtesy green tint to it. These ones with green tint, also let me back up and say there's nothing in C++ that says built-in types will always be seen as green in your editor, right? As far as the compiler is concerned, it's all just text and color doesn't enter into it. And it's referred to as syntax coloring or syntax highlighting. That is a peculiarity of the editor you're using. And it's easy, let's see, it's easy to turn it off. Right. So when I was cutting my teeth before the days of graphical terminals in multiple colors, all of my programming was done looking like this. Actually, it would have been a black background with the green letters on the old style CRT monitors. So the oops, another way to do that is just to get back in there. All right. So it's the editor that's providing that for us, and it's going to be different from editor to editor. And even within Vim, I'm just using some default configuration. I'm sure there are people who trick out their Vim settings to do something even custom with regard to the coloring. So the only reason for saying all that is to say that that's just a courtesy provided to us by the editor. It doesn't have anything to do with the language. However, there is a reason why they didn't make string green like the rest of them. And that is that these types in green are actually built into the language. I'm not quite sure how to term it other than that. Kind of like the looking at molecules and stuff. These are the atoms, right? You just can't break it down any smaller. You have a character, you have an int, it's just intrinsic part of the language. String, as it turns out, isn't built in as part of the language the way these others are. There's actually a programmer somewhere at some point in the distant past who wrote some code to create this string that we're all using. It's a little bit beyond us right now to talk about why, except to say that C++ came from C, and C didn't have any concept of a string. So that's part of it. But with all that said, the beauty about this string type is it's been designed to behave exactly as these other built-in types. So I can do things like, let me create a string name, and then let me say that name is equal to Todd. And note that I've commented out my using namespace standard. String is part of the standard library, so I'm going to have to do that. And then I want to spit this out. Let me compile it to make sure that everything's looking good. Alright, so that works fine. So when I said that they do a pretty good job of making this look like something nice and built-in and kind of behaving like the built-in types, I can do things like name equals name plus, how about a space, an A, so that's my middle initial. And actually, let me go ahead and just do this. Okay, so you can actually use kind of these algebraic expressions to kind of add together strings, which is intuitive and makes some sense for you to look at. Let me pull this apart in terms of expressions. There are two operators that work on line 9. So two operators on line 9. One is the assignment operator, and the other is the addition operator. Okay. And each of these operators has a precedence, and we're familiar with operator precedence from simple algebra. For instance, I'm not going to throw anyone for a loop. If I say, what's 5 plus 4 times 2, no one's going to say it's going to be 9 plus 2. Everyone's going to know the multiplication occurs before addition, and you're going to multiply the 4 by 2 and then add the 5, right? So the exact same thing holds in C++, and all the mathematical operators are exactly the way you'd think. There's nothing unusual about it. If I was to use this in a C++ program, it would make the multiplication occur before addition. However, every single operator will sit on what's called a precedence chart, and I'll show you that in a moment, ranking things from higher precedence such as multiplication and lower precedence such as addition. These two less than signs, this insertion operator, which I've been calling the chevrons, these chevrons are operators as well, so they could be used in an expression. And this equals sign, this assignment operator, is in this precedence chart as well. Let me actually just show the precedence chart. I can type C++ operator precedence, and there will be somewhere between 20 and 1,500 of these on the web somewhere, looking different depending. So there's going to be a lot of stuff here that we haven't seen and don't understand yet, but the general format of the table should make sense. So the lower the number, the higher the precedence. So this would be the highest precedence, next highest precedence. And to look at something that you're certainly familiar with, you will notice that, make it even bigger. Multiplication and division is happening before addition and subtraction, right? Higher precedence. But here you see the chevron. So this pair of chevrons is being used for C out. This is being used for C in. So you could have a multiplication symbol, an addition symbol, and this left shift or insertion or chevron or whatever you want to call it, all on the same line, and the compiler would pick it apart and make the multiplication happen first, the addition happen second, and then the chevron would happen below that. And that's when I do something like this, I take this expression I've got three operators here. I've got this operator twice, I've got this addition operator, and I have this multiplication operator. All right? And so what the compiler does is it simply takes all the operators and figures out the precedence of them and starts crunching down the expression. So coming to this chart, multiplication happens before addition, and addition happens before this insertion operator. So the insertion operator happens last. Multiplication happens first. So if I was to kind of run through this, it would first crunch this down and make that, how do I want to do this? I don't know quite how to space this so it looks intuitive. Maybe like this. So the first thing is the multiplication to get the 8. And then next will be the addition, which is going to be 13. And then there are still two operators here. So what happens if I have 3 plus 2 plus 4. How do you evaluate that? Left to right. Left to right. Left. You see there are a couple that actually go right to left, and we'll look at those in just a moment. You'll see the most of these go. Most of these, if you count them up, are going to go left to right. So once we get to this point on line 16, then it's going to go left to right. And it's going to, and this will be the most confusing part of it, it is actually going to evaluate C out the chevron in 13 like an expression. Now the expression isn't going to do what we think of in terms of mathematical expressions, in that it's not going to do a mathematical manipulation on some number, but it is going to do something. And you and I, hopefully at this point, are comfortable with the fact that it is going to do this operator is to take the action of putting the 1 and the 3 out on the screen. Okay. So the question is, what is the result of that operation? So what do I mean by result? So 3 plus 2 plus 4, the observation was made that that occurs left to right. It's going to add the 3 and the 2 together. What is the result of that operation? What ends up sitting right here for the plus and the 4 to operate on? 5, right? There's something that happens, and then a result sits there so that other operators can use it. Yes? The 5 has to sit there so that the plus and the 4 could be operated on. So there actually has to be a result to the C out less than 13, so that whatever comes back can then be operated on. So let me do the same thing. Let me put the question marks here, and then so that this can occur. What does endline want to work with? Oh, I hear it. C out. So what do you think the result of C out less than 13 is? C out. That's actually what happens, is it runs through the process of putting the 1 on the screen and the 3 on the screen, and then what comes back, what is returned from the expression, just like a 5 is returned from 3 plus 2, C out is returned from C out chevron 13. And now it can do this last bit of the expression, which is to send a new line, an enter, if you will, a new line out to the screen. Okay, and we'll look at this some more. So this is, I think this is probably really weird and hard at this point to get your head around, but we'll look at it over and over again, and it'll start to make some sense. But that's the way the entire language works. Let me take it the final step. For this expression, if I was to let me create an integer a, and then let me say that a is equal to 3 plus 2 plus 4. And I'll put the spaces to make it look pretty. So if I look at the equal and the plus, here's the plus way up here at level 6, and then way down here at level 15 is what they're calling direct assignment. This is the assignment operator. So the assignment has to happen long after the addition happens. Okay? So if the addition is going to happen first, then we have a bunch of addition operators, goes from left to right. So we end up with 5 plus 4, 9, and then this operator, what this operator does is it puts the 9 inside of the A. But this expression ultimately returns something. It returns an A. So when this thing, almost every single expression you're ever going to encounter gives something back. 3 plus 2 gives back 5. A, assign 9 to it, is going to give back A. Now I said I'd come back to right to left. So here's the right to left designation, and that's what's given to the assignment operator. So that means that assignment goes, the 9 going from right to left, assigning to the A. So that makes some intuitive sense. But you can start to do things that from a mathematics perspective are really odd but work beautifully in the language once you get your head around this idea of expressions always just taking the highest precedent operator, doing the manipulation, it gives something back. Then you take the next highest level operator, do some manipulation, gives something back. And you can do things like this. So I'm going to create an integer a. Well, I've already created a. Let me just do them up here. I'm going to do b, I'm going to do c. And I'm going to do something like this. I'm going to say that a is equal to 3 is equal to b is equal to c is equal to 3 plus 2 plus 4. So we know that based on the precedence here that the additions are all going to occur. So I'm just going to simplify matters since I've already done that on lines 23 through 25. And I'll just say that we are eventually going to get to this point. Okay. So we have a whole bunch, so just like a whole bunch of addition operators get evaluated from left to right, a whole bunch of assignment operators get evaluated from right to left. So the 9 gets assigned to the C. So we end up with A equals B equals C, where C is equal to 9. And then what happens next? C is assigned to B. What's in C? 9, right? So the 9 is assigned to the B. So we end up with this. And then B is, and then B is assigned to A. And what's inside of B? Well, 9's inside of B. So the 9's assigned to the A. And then you end up with this. And then the compiler gets to this point and says, there's no more work to do. Now it's time for me to go to the next line of code. So that's the way the compiler is working with every single line of code, is it's evaluating it as a big complex expression, shrinking, shrinking, shrinking until there's nothing left to do. Then it'll go to the next line of code. Okay? So, any questions on that?
I have a question.
Yes.
Why wouldn't you use namespace standard? Like, that seems very painful to just like throw those in.
Why wouldn't I use it?
Yeah, like why are you not using it right now?
Right, because I forgot. Oh, well, excuse me. I misstated that. It's taking a step back. Since I didn't do it, I should have put them in, but your question still stands. Why would I ever not do it? Because it's a lot easier than me forgetting, coming back and having to do what I'm doing now, which is a lot of extra typing. The reason for, so I guess the short answer to your question is probably the majority of the time you would do line 2. Or you would do something very similar. You can kind of, when I say using namespace standard, the standard library is absolutely huge. Okay, and there may be a reason for me to not want to be able to invoke that entire standard library without the std::. I'll explain why in just a moment. But just to say it, I can do things like this. If I do that, then anywhere in my code, I no longer have to say std::cout. I can just say cout. So it's like to say for this one thing, this for cout, I no longer have to do std::. I could do it for endline as well. So I could, just to say it, I could do these 2 lines, and then I could get rid of all the std::s down here on lines 16 through 19. But your question is, well, why would, okay, Todd, so big deal, you really haven't answered my question. Why wouldn't I do line 2? Or if I don't do line 2, why wouldn't I do lines 3 and 4? Why would I ever leave those out and force myself to do what I've done on lines 16 through 19? And the reason is that you have to go back to the C language for, I guess, some of the motivation for wanting to do it. So we haven't done a lot of writing functions yet. Functions come a little bit later in the course where we really start spending a lot of time with them. But I've given an introduction to say I can at least create I can write my functions. And in this function, I can say my var, let me see what I want to say, return my var plus 5. Right? And this is a little simple function. But given that the language allows me to write functions, it's reasonable to assume that any properly sized professional application will have hundreds, thousands of functions in it. Okay? A whole area of where you can make money is you can create libraries of functions that are useful to people and sell them. And normally what you would do is you wouldn't sell the source code to it. It depends on the business you're in. There's a lot of open source out there now, but it's certainly reasonable to think that you wouldn't sell the source code, but you would sell a compiled version, so you can use my function, but you're not allowed to look at the source code and rip me off, right? And so what might be a context for that? Maybe you cater to gaming companies and you've got this awesome library of mathematical manipulations that do linear algebra and spline and all sorts of things that are relevant to game programmers working with the 3D graphics and so forth. And so you give me $100, I'll give you this library to use. Well, what I've just given you is a library and it has my functions in it, and one of my functions is called I guess it doesn't matter. I don't know why I'm sitting here thinking about it. Let's say my function's called Bobby, just because I got to keep the lecture going and I can't sit here trying to think of a proper name any longer. But here's the deal: you buy my library, and the owners. So you buy my library to use in your company, and your company already has 1 million lines of code invested in your product suite, whatever it is you're making, your games or whatever. Well, it turns out that the owner's son's name is Bobby, and the owner is a bit of an asshole, and he said, I want you to have lots of functions that kind of have to do with my son, and so you've got this function in there called Bobby. Well, I just gave you you just bought a library from me that has a function named Bobby. Now you can't use my library, because if you ever try to use the function Bobby, the compiler won't compile, because it will say, are you talking about the Bobby in that library you just bought, or the Bobby in the code that you just wrote? So there's a conflict there, right? You can't have them. In other words, the bottom line is you can't have two functions with the exact same name. All right. So what's a solution to it is you wrap a namespace around it. So what I would do is I would say namespace Todd's Cool Company, and then I would put all of my functions in this namespace. Now I sell you my library. Now if you want to use my Bobby function, you would say Todd's Cool Company : Bobby. And now the compiler knows exactly what's being talked about here. Okay? And so getting back to this, why would I ever leave this off? Well, as I said, the standard library is very large and there's a lot of stuff in it. So it isn't unreasonable to assume that your organization may have code in it that has names that are identical to names that have already been taken by the standard library. So in that case, you would not say using namespace standard, because you want to avoid that conflict. And whenever you want to use whatever from the standard library that has the same name as your code, you'd put the std : in front of it, and there's no ambiguity. So that's a very long-winded explanation for why, but that is why. Mm-hmm. All right. So, expressions. What I want to introduce you to are Boolean expressions. Bool is a type. It didn't exist in C. I mentioned there's sometimes where I'm going to say in C and C++. For those unfamiliar with the background, C is a language that's been around a long, long time. And C++ came decades later. C++ is a language that is a super, I guess it'd be proper to call it a superset of C. Just about anything you do in C would work fine in C++. But C++ adds a bunch of other stuff. Anyway, so there are things in C++ that don't exist in C. One of them is this particular type called Bool. You'll note that I get the green highlighting here. And this is a variable that can take on two values, either true or false. And those are keywords you can use. So I can say my Boolean variable equals true. And you'll see that it actually put the word true in this red highlighted color, the same way it does these literal numbers, 13 and 5. So this is a keyword in the language that you can use for this kind of thing. And we can use these variables in expressions to make decisions. So to this point, when we run a program, it does the same thing every single time. We would like our program to have choices and then branch out depending on the value of the choice. Let me see. I've got quite a mess here. I'm wondering if I think I'll leave all this stuff for the sake of posting it to the daily diatribe. But I am going to move on. And I'll call this bools.cpp. And then I'll just delete all this crap from it. Another Vim thing I can say from lines 1 to 9, no, to 12, delete. And I'll get rid of some of this stuff. Let's see, where's the end here. So from line 7 to 39 I want to delete. And then I'll leave this, I'll do this stuff this time. Alright, so I can create a Boolean, my bool. Oops. There we go. Now, there is what is called an if statement. If statement. If. So, an if statement. What is the syntax? Curiously enough, it includes the word if. I'll give you. So that's a general format of it. Note that line 9 is a comment, right? So that's not part of the if statement. So the first question is, what do I mean on line 11 by statement? A statement is literally an expression ending in a semicolon. What is an expression? That's what I spent the first half of this class talking about. Anything you can slap together with operators, right? So I can do something like if my Boolean variable equals true. Now I'll talk more about all of this. How about cout? It's true. All right, now this isn't the most exciting program yet. But just stick with me. So I create a variable, I've assigned a value to it, and then I'm asking the question, does this variable contain true? And if it does, I'm going to say it's true. And of course, I've said that it's true up in line 7. So let's, just to make sure I don't have any compiling errors, let's go ahead and compile it. Ooh, I do have compiling errors. Oh, that's because I have this. So I'm just going to comment that out. Let me see. Let me make this a little more clever. There we go. This is what's called these double slashes, like I have here, C++ style comments. They go from the point you have the double slashes to the end of the line. The C language gave us these multi-line comments, which start with a slash star, and then every single thing in your program's a comment until it sees a star slash. So that's what I've done there. All right, let's try that again. I'll do !G to rerun the last command that started with a G. which is G++. It compiled, I run it, and it's true. All right. Likewise, I can come here and use that other keyword, false, and I should, when I compile and run this, I have no output because it's not true. So this is doing a comparison. It's evaluating this expression, and if the expression is true, it will do this line, this statement. If the expression is false, it will not do this. Now, what goes inside here? An expression. And an expression means everything that I said starting at the beginning of class. Anything that you can slap together with pluses, minuses, chevrons, doesn't matter. Do whatever you want. It's just this big trash can that you throw your expression crap into before you take out the garbage, right? You just throw it in there, and if, when it's done crunching, remember all these expressions give something back. A lot of these operators are binary. They have a plus, 1, 2. By binary, I mean 2. There's something to either side of the plus. Binary operator crunches it, gives us something back, and then it takes another binary operator, crushes it, gives us something back, right? When you're done crushing, you're always given something back. Whatever's ultimately given back, that is what the if is looking at. Is that last thing true or false? Okay. Now, with Boolean variables, if you had the word true, it's true. If you had the word false, it's false. True and false in the language, however, is much more general. And this is very, very important. False is 0. True is, and I'll put this in uppercase, like some internet rant, everything else. Everything else. Get this in your head. If it's 0, it's false. Anything else. That is everything. Whoops. Undo. Hang on. Is everything and anything else. Right? So, give me an example of anything else. Huh? Say it again.
10.
10. Yes, 10 is true. Be more creative. Those are numbers. Give me something that's not a number.
Q.
Q. Yes. This is the character Q. That's true. This is the string Todd. That's true. Anything else is true. Got it? Anything else is true. This stuff comes up on the midterm. Commit it to memory now. Anything else is true. Just 0 is false. 0 is the only thing that's false. So, actually, let me take that out. Let me do this. I'm going to say int a equals 5. Now, look very carefully. What am I doing on the expression on line 17? All right, I heard the key word there, assigning. Yes? I am assigning 9 to A. And then go back, rewind the lecture 15 minutes or so. Assignment goes from right to left. Not that that's really important here, but the 9 gets shoved inside the A. What is the result of that expression? Don't evaluate it with the if yet. I heard A. A is the result of that expression, right? Because I remember I went A equals B equals C equals 9. 9 went to C. C was the result of that expression. C went to B. B was the result of that expression. B went to A. A was the result of that expression. There's no more to do, so we moved on. Okay. 9 is assigned to the A. The result of that expression is A. Now, ask the question, is A true or false at that point? Is it 0 or is it anything else? It's anything else, so it's true. All right? Okay, this is a big point of confusion. Now let me ask a different question. What am I doing on line 17 now? I'm doing a comparison for equality. That's a totally different operator in the language, right? So that's this right here. So it's not assigning 9 to A. It's asking a question, is A equal to 9? And is A equal to 9? Based on line 16, it's not. A is 5, A is not 9. So what is the result? What is returned from the expression is A equal to 9? Yeah, 0 or false. Either answer is fine. Yes?
So then you can do, if you can do, is it equal to, can you also do a greater or less than?
Oh yeah, sure.
Is that the...
Everything you're accustomed to in algebra works, so you can say if A is less than 9.
Okay.
And that's true. Yeah. Is A greater than 9? That's false, right? Okay. So you can save yourself a lot of grief because, and this happens to veteran programmers as well. It certainly happened to me within, say, the last 5 years. You accidentally forget that second equal sign, and when you've got 100 lines of code and your eyeball's scanned by line 17, and you go, I'm asking if A is equal to 9, and why the hell isn't it doing this? And so the problem is that I think in my head that I'm comparing the two, but I forgot that other equal sign. So in fact, what I'm doing is I'm assigning 9 to A, in which case it's always true, because 9's always true, right? So when you're doing these if statements, make sure you're doing what you want to be doing inside there, either comparing two numbers or assigning a number. Okay. So now we can make this more useful by, rather than hard coding, saying something like this. On line 7, I can ask... in fact, I don't even need to use the Boolean at all. I could do something like this. I'll create an integer A. In fact, I'm going to give it a more useful title of the variable. I'll use age. I'll create an integer age, and then I'll say cout. How old are you? And then I'll say cin. Whoops, I want to come up here. Let's see, I'm going to add std : cin. And I'm going to say cin into the age variable. And then I'm going to say if age is less than 23, see you at the bear tonight. Okay. I'm going to introduce another aspect to the if statement. This will stand alone, but you can tack on another thing, else. And the syntax is if expression statement, else statement. Okay?
That's like the one you're using in the maze thing. The blocking.
Yeah. Else, get away from me, old man. So, if you recall at the beginning of the semester when I gave out my cell phone number, I said, you know, that I sometimes get the 2 in the morning texts. I've been to the bear with students, and there's this period of time between 10 and 11 at night where at 10 at night, you know, you're just one of the group hanging out, socializing. About 11, it turns from that point where you're just one of the people they're socializing to being the really weird old man at the bear. Okay? The median age drops to everyone your age, and everyone kind of, you know, you're wearing the nicer clothes, and everyone kind of looks at you like, why are you here? Don't you have a life? So, aren't you supposed to be asleep? So let's try it. How old are you? 21. See you at the bear tonight. How old are you? 20. Well, let me see. I'm 28. Okay. So there you go. 2 more things. I've got 3 minutes. I'm going to need all 3 minutes. There's one of the limitations here is you are only allowed to have one statement. Okay? But the language provides a facility for you to get around that. and that is that you can create a block of code. So a code block is one or more statements surrounded by curly braces. Anywhere you can put a single statement, you could put a code block. So if I want to do shoot, I don't want it bleeding on another line. This won't work because I'm only allowed to have one statement. However, anywhere I can put a single statement, I can put curly braces. So if I do this, that works fine. Anywhere I can put a single statement, I can put one or more statements surrounded by curly braces. If I do that, then it'll work just fine. Okay. So keep that in mind. The same goes for the else. A lot of times a mistake is made. This is a mistake that's often made. If a equals 5, do this, do that, and people can't figure out why sometimes it does do that and sometimes it does both do this and do that. That's because this only allows one statement, so the way the compiler interprets it is like this. It asks the question, if this is true, it does this. Then it's just moving on, and this is another line of code that it always does, because this isn't part of the if statement. If I meant it visually on our eyes, remember the compiler doesn't care about spacing. If I meant for this to be part of the if statement, then I have to remember to put the curly braces. Yes?
Would you be able to put like another integer within the curly braces?
Like that?
Yeah.
Oh yeah, absolutely. You do whatever you want in there. About the only thing you can't do is actually define new functions in here. You can call functions in here. You can't define new functions in there. That's about your only limitation. Let's see. I think that there's more to say, but I think I've done enough to make this a fair point to stop. So we will see you in lab and see you on Wednesday.